Hello. Hi guys, good morning. Welcome back to video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see a problem. Zero array transformation 2. Again, we have already seen zero array transformation 3, and one is pretty easy. Let's see this one. This is a pretty interesting problem. It simply says that you are given 2D integer array queries. So this is query which is given to you. As you can see, I have given some query which is a 2D integer array. You can see what this represents is L, R, and the value. So I have a left, right, and the corresponding value. What does this mean? This means that my each query of I, which means each of the specific array, it represents some action on my nums. What is the action? Action is decrement the value at each index in the range L to R in nums by at most value of I. So in this range of 0 to 2, 0 to 2 index, so index 0, 1, 2, index 0 to 2, I can decrease every value by at most value, which means either 0 or 1. If let's say that in the range 1 to 1, you can decrease by at most 3, which means either 0, 1, 2 or 3. This is the value. So as I read the first line, which means decrement the value in a specific range. So I'm thinking about some range operation being applied. And again, forget about at most. Always break the problem down. In this, again, I haven't even read the further part. No, I have just read this line. And with this line in mind, we realize that, okay, it's a simple range update. Now, obviously, we have two things. Either we can use a diff array, again, a prefix sum. There are multiple variations of prefix sums. It is one such that, or other we can use is segmentary of Venn victory. As you can see, it's a range update in this specific query. Range degrees. Now, when to use this? When you only have to read the queries first and then action or answer those queries later on. When you use segmentary of Venn victory, when you are reading and answering the query simultaneously. That is the thing when you have to use it. Now, if the problem would have said that I will read all the queries first and then will action or give the answer that let's say if I say that okay, all these queries when done, if they give me answer or not, then okay, I will use my prefix sum. But then if I just ask, okay, this is the one query, then it is being applied, then I want some answer, then it is one such query, it is being applied, then I want some answer. So in that case, I might tend to go towards segmentary and victory. Again, obviously it's a bit tricky to write the code and stuff, so usually there's a chance that if you have any medium problem, it should be solved by a simple prefix sums technique. Now, if you don't know that technique, I'll highly recommend go and watch this video only. You will get it. I'll explain it. Now, coming on, what they are trying to say, the amount by which each value is decremented can be chosen independently. So as we said that it can be chosen independently for the entire array. So if I say that decrease the value by at most 3 in this range, let's say take this range 0 to 2. I can decrease by at most 1. So I can choose. I can decrease this by 1 and this by 0, this by 0. Again, I can choose independently. What I mean by that is if I have some range and I'm trying to decrease by at most value, then again this value also is independent, which means that it will try to decrease the individual values as and how it wants. For example, I have this array. Now my value is 7. Now again, my ultimate target was getting all these values equal to 0. That's my ultimate target. So I will end up taking, again, as I said, I can choose at most value, which means I can choose the value at most a 7. So I can decrease this by the value of 4, decrease this by a value of 2, decrease this by a value of 3, decrease this by a value of 7. This is exactly what I can do. Again, what if the array value would have been 9? Then I can do decrease at most value 7. So it will still remain a 2. That is what they're trying to say here. Cool. So again, if I just simplify it, I can simply rephrase this statement by saying that my ultimate target would be making all the elements 0 or negative when I will decrease all the values in the range L to R with the value 7 or with the value. I'm not referring at most now. I have changed the other condition by saying that now my ultimate target is getting things 0 or negative, which means this will become -3, this will become -5, this will become -4, this will become 0, and this will become 2. So you see that I have changed this condition. Now the condition has become that the ultimate L to Ri value has now become valid. And also, again, I can now in L to R, I can do a complete subtraction of value. Cool. Let's proceed forward. So far we have seen many hints. Like these are not hints, these are from the question itself, what we should be knowing before we proceeding forward. And that's ultimately the essence of intuition is. Cool. Ultimately, you have to return the minimum possible non-negative integer case such that after each process, after that processing, the first k queries in the sequence in nums, it becomes 0. So ultimately, you have to tell what is, obviously you have to process the queries from left to right. He's asking for the first k queries which can result in this entire nums value to be 0. Obviously we have changed the condition now, so for us the condition is becoming the entire thing as 0 or negative, right? 0 or negative. Again, why we change the condition? Because it is much more easier to work on val rather than working on at most val. So I have to delete the at most word just to make it easier, and obviously it is much more easier and convenient to think of the array can become negative or 0. So it's ultimately a very small condition like this which I can put up in my array just to validate, but handling at most will help, like would have resulted in handling all the numbers, 0 1 2 3, which is pretty cumbersome and also could be time consuming as well. Coming on forward, we realized, okay, this is the case. So what is the ultimate thing? Ultimate thing is primarily same thing, do exactly what they are saying. What they're saying, they are saying that give me the first k queries, whatever you have, which can result with the entire array as negative. So forget about the first k. I ask you choose any random. I choose, okay, choose any random number. Like I choose three queries. So obviously I'm choosing starting three queries, which means all the queries I'm choosing. Now I'm asking you, can you get the entire array nums as negative or 0 or not? That's the question. So obviously you will try to apply a technique, which is the diff array technique. Diff array says that, okay, at 0 I will add value I, and at r plus 1 I will add minus 1. Now, how this helps us is because if you see a very normal concept of diff array, it says that if you have any range, in that range you are applying some operation of plus 2. And again, if you want to apply operation of plus 2 plus 2 plus 2 plus 2 like this, if you want to apply operation of plus 3 plus 3 plus 3 like this, if you want to apply operation of plus 5 plus 5 plus 5 like this, if you want to apply operation of, plus, okay, like this you want to apply, then diff array says that, okay, you were doing a range update like this, right? Range update like this, rather do one thing, plus 2 apply here and plus minus 2 apply here. Okay, then this is gone. Same way, plus 3 apply here and then minus 3 just after it, which means here I will add minus 3 here, it will go minus 5. Same way, plus 5 will apply here, it will become plus 7, and then minus 5 will apply here, minus 5, as you can see after it. Now what will happen is when I will take a prefix sum of it, I will get something of this sort, right? I'll get a plus 7, I'll get plus 10, I'll get again, sorry, this is the array like this here, and then I have another array here. Yeah, I get another plus 10, and then a 5, and then a 0. What this ultimately this indicates? This indicates the final contribution of all of this ultimately. So no matter how big your updates are, I just for every update, for every range update, I just updated 2 points. This one, which means I updated the point L and R plus 1. I updated the point L with the plus 2 value and R plus 1 with the minus 2 value. And that is I did for all the queries or all the range updates. And ultimately, when all the range updates are done, I took a prefix sum. And that prefix sum ultimately told that at each index, what should be the addition? What should be the addition? And it will exactly be same if I take, this will be 7, this will be 10, this will be 10, this will be 5, this will be 0. So this is exactly what I was looking for. And this is your diff array or a prefix sum technique which we have. Okay, let's do the same thing. The question was that taking the three queries. So I will take 0, I will add up plus 1, right? 2, or I should say 3. At index r plus 1, I will do a minus 1. Okay, first one is done. Second, I will take 0, I'll add a plus 1. At r plus 1, I'll do a minus 1. Minus 1, okay. At 1, I will do a plus 3. At r plus 1, which is 2. At index 2, I will do a minus 3. Minus 3. Now, when I will take a prefix sum of it, I will get 2, 5, 2, 0. just 2, then 5, and then again 5 minus 3 will be 2, then 2 minus 2 will be 0. This is the prefix sum technique. If you don't know what prefix sum is, I'll highly recommend come on to the crash course section. Again, how to come on? Come on to the website, come on to crash course. In that you will find the array, 2 pointers, and then you have a prefix sum. Just go and watch the prefix sum, you'll get the prefix sum idea. Coming on back. Okay, I guess I'll update this to a prefix sum one. But yeah, now coming on back, we realize, okay, this is the essence. Okay, great, awesome. Now, what to do now? Obviously, what is the time complexity which will be required if I approach the same thing? Did you forget the question? I should. I think you should not forget. Your task was to find the first k queries. Here you choose some random k, which means the k was 3. So you were choosing starting k as you were choosing starting 3 queries. And then you were trying to find the answer. But obviously, you have to try for first k, which means you will try for first one query, and if not possible, then first two queries. If not possible, then first three queries, and so on and so forth. Which means that you have q queries. You have q such configurations or q such queries. You each and every for one such configuration, which means when I said k equal to 3, then you firstly build this specific diff array which mentioned that go on to each and every query and update that corresponding diff array. And then when the diff array was built, you were taking the prefix summation. So obviously building a diff array will take O of Q time, and then building a prefix sum of size n will take O of n time, just to iterate on the prefix sum. Okay, so for one configuration, when I say when k was 3, for one configuration, you took O of n plus q time. And as we said that we will try for multiple configuration, which means k equal to 1, when the first element only, k equal to 2, starting 2 elements, and then k equal to 3, and so on and so forth, until I get a specific configuration which is the valid one. So I will try that for q configuration because I have obviously q queries. First one, like only first two, first three, first four, and so on and so forth, and until first q. So I will use q configuration. Each configuration taking O of n plus q time. Obviously, it will take q into n plus q time, which will obviously give you TLE, because if you look at the constraints, q number of queries are 1e5 and n is also 1e5. So my complexity right now is 1e5, which is for q, into 1e5 plus 1e5, which will obviously give you TLE. How to go about this? Did you see a very standard thing which we are doing? We were doing a linear search here. We were trying for, okay, search for 1, then 2, then 3, and so on and so forth. Obviously, as an intuitive fact, we might think of binary search, but still, binary search is the concept that your pattern should be wrong or right? And that's the reason you will be able to figure out a simple place in binary search where you can land onto. And that is the thing I have to prove that, okay, this is the pattern for binary search. And yes, I can prove that because you were trying the first k equal to 1. Then you were trying k equal to 2. Starting k. Then you are trying k equal to 3, starting 3 queries. As soon as you got one, you will stop. Which means obviously if you take more such intervals or more such queries, you will obviously have a liberty of making your numbers more negative, in terms of when the actual diff will keep on adding as I keep on taking more queries. That is the beauty. And that is the reason every of these queries on the right side will keep on always keeping your answer. But this only, first query, or like only first query could not give you the answer. That is the reason it was a wrong. So it follows a pattern of wrong, 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 which means that only first query will not give you, only starting 2 queries not, starting 3 queries not, starting 4 queries not, starting 5 queries will start giving you, starting 6 queries will start giving you, and so on and so forth. Thus I can apply a simple binary search on k, that how many of such starting queries I can take. And when I fixed that, okay, now k is equal to mid, I will take mid number of starting queries, then I will simply say, okay, Aryan, I will take mid number of starting queries, which means my mid is, let's say, here. So I'll take these starting queries. Then I will simply, again, this is how I find mid with help of binary search. Now I will simply go on and find the diff array, then take the prefix sum. Finding diff array will take O of q time, prefix sum O of n time. Thus, O of log q time for doing a binary search, finding the mid. When the mid is founded, then finding the diff O of log O of q time, finding the actual array prefix sum O of n time. And this is my time complexity which will simply work. Right? Most intuitive way is binary search. Again, we'll see one more way, but yeah, this is the most intuitive one. Let's see the code. It's exactly same as what we discussed. Firstly, we will have a simple check that if I can transform using the entire array or not. Although this is not required, you can handle this condition here as well, right? In the end as well, you can just have another variable called as answer, initialize with -1, and then as you are putting up, you can just put that okay, answer is equals to mid, and then again, because your mid actually will be your left to right, which means corresponding indexes in consideration, so you can change it accordingly and then give out the corresponding answer itself. So again, there are multiple ways to write the corresponding binary search. If you don't know, please make sure that you come on to the crash course section and make sure that you are good with binary search basics, this video which gives you a template of binary search. Now coming on back, we realize that okay, we are pretty cool with it. Now we will simply have a quick check that if I can transform things, great. Okay, if not, then I'm screwed up. Then I will say okay, L to R, just simply start your binary search with, then keep on finding and see if you can transform, then okay, move on to a smaller value. If not, then a smaller, which means less number of keys, and then if not, then higher value of mid. And how to do the transform? Just make a diff array, as we said, that get your start, get your end, which means get your start and end. And then start, you do a plus, end plus 1, you do a minus, and then take a prefix sum. You take a simple prefix sum by taking sum plus equal to a diff of array of I, and then if any of the nums of I could not become 0 or negative, obviously you are screwed up. Simply return false here only. If not, ultimately you were able to have all of the sum more than equal to your nums of I, which means that your sum which is being built up, if it is more than equal to your nums of I, so obviously whenever you will subtract sum from nums of I will become negative. And that's what I wanted also. So just making sure that if you can make all of them negative, your answer is true. And with that, you will simply get your time complexity as O of log q into q plus n. Now the catch is that although this is the most intuitive solution, and if you are good with it, like if you got this, then awesome, you are good with it. Can you improvise it is the question. Whenever you see improvisation, obviously we are trying to go towards, obviously we cannot get rid of O of q plus n. This is impossible. You will have to go to all the queries, and you will have to go to all the numbers as well. But if the person is asking me to improvise, he is obviously asking me if I can get rid of this log q, which means I obviously have to start thinking of in terms of that I cannot do binary search, and neither I can do a linear search. So then what? Obviously now comes that I will do search parallelly. What do you mean by parallelly? Parallel, which means building your diff array parallelly while trying to see that if the condition is being satisfied or not. Okay, it can be a bit complex. Let's see how. So, okay, I will do parallelly. I know that my task was that minimum number of k. Again, here I have put k as 1, but make sure the index is 0. So in the code you will see I have put up as -1. Index is -1, which is k minus 1. But yeah, it indicates that I have chosen k queries. Now, my task is that I will only move ahead in my queries, only if it is required, and I will move ahead in my nums of I when I can be sure that this specific nums of I can be decreased to 0 or negative. Okay, now let's proceed forward. So firstly, again, I will have to parallelly build the diff array. Along with it, I will have to parallelly take the summation, because again, everything now needs to be done parallelly. Why? Because obviously you cannot do a linear search here, and again, you can figure out something that you are not doing things here parallelly, but still it cannot come as a loop, for this one loop and then another loop for other things in the same iteration. Okay, let's see exactly with the help of a dragon how exactly we can do it. So firstly, we realized when I land onto index 0, okay, my first query was 0 to 2. I checked that 0 to 2 in theory will impact index 0 to index 2, correct? And my index is 0, so obviously this will impact me. This will impact me. If this will impact me, then what is the impact? Impact is plus 1 and minus 1. So I'll do a plus 1 and a minus 1. But, and again, when I do a plus 1 and minus 1, I know that current sum. What is this current sum? This current sum is actually the prefix sum, which I am now maintaining parallelly, because I cannot take, because see, if you remembered earlier, firstly, we were building the entire diff array and then we were doing a prefix sum, right? But now, parallelly, I will make a prefix sum as I'm moving forward. Right now, I haven't moved forward. I'm still at index 0, which means I'm still standing here. So far, the sum is 0. But you will say, I don't know, sum is 1 right now, right? Yes. So sum is right now existing sum, whatever I have, plus whatever I have built so far in the diff array, which is 1. So this is actually the sum, which will be updated soon. But right now, this is the potential sum which I have, which is sum, existing sum plus diff of I. Okay, so my sum is 1, but I require 2, obviously, because I require 2. So obviously this will not handle. So first element will not handle. Okay, no worries. Move on your k. Your k will simply move. Now I have now, okay, my I is still here because this was not satisfied yet, but I still had to, worst case, I had to move my k. As I moved my k, again I know that my index is 0, and this specific index, it says I am from 0 to 2. I am from 0 to 2. Now obviously in that case you will say, Aryan, that makes sense. I will do a plus 1 and minus 1 here. Plus 1 and minus 1 here. Perfect. Yes, you will do it. And as you do it, it was earlier plus 1, it will become plus 2, it will become minus 2. Now your current sum is sum plus your diff value. Yes. And now it is more than or equal to my nums of I which I required. And that is the reason now I'm good. Now this will be handled. Okay. Now let's go on. Okay. As I go on, obviously, now I am handling again. As I go on, now I'm trying to handle this thing. So obviously, before you go on further, make sure that you update your sum with the previous sum. So this is now your sum, which I did add on the basis of my diff of I. Cool. Okay. Now the state is my sum is 2. Now I am standing here and this is the value. Obviously, my sum is 2. And even if I don't incorporate this one, my sum is 2, which is higher than my nums of I. So I'm good, because as I told, I want the numbers negative or 0. So 0 minus 2 will become minus 2. So I'm good. Okay. Yes, I will proceed forward. My I will come here. Okay, as my I comes here, I am now standing here. Again, my current sum is 2. I don't require anything else, okay? Because here the diff is 0, my current sum is 2. I don't require literally anything else. So what I will do? Obviously, I will make sure, okay, it is okay. Then move your I. Oh, my I is finished. If my I is finished, I was only able to capture, with only two such queries, I was able to get my answer. And that is your answer itself. So technically, again, people have mentioned it as line sweep, but yeah, I more mention it as a 2 pointers, because you're kind of moving 2 pointers in both of these directions, queries and nums, and then finding the answer. Now, there's a quick catch here, that how you will formulate it as a code, because again, understanding with the help of example is easy, but code needs to be having a bit of nuances here. So okay, let's write the code itself. So obviously, as we mentioned, that we'll simply iterate on my nums of I. So I'll simply iterate that, on my nums of I. At every step, I will iterate on it. But for each nums of I, it needs to be completed, which means that while my nums of I value, which means current sum plus my diff array, as you remember, diff array of I, if it is less than my nums of I, then I need to keep on going in what? Keep on going in my queries array. So if you remember that you were checking, if you remember, like you were having 0 and then you were checking with diff of I. So current sum plus diff of I, because again, sum will be updated later on with the actual value of sum. So technically what will happen after this while loop, I will have to update. Let's erase this portion and say that I'll now update and say sum plus equal to diff of I. So technically now to get the proper sum, I have to take sum plus diff of I and then compare it against my nums of I. Okay. And again, as I mentioned, while it is less, I have to make sure that I keep on accepting more queries. When I accept more queries, which means obviously I'm increasing my query count. So let's say query count is increased. I have accepted one more query. Now, query acceptance is okay. What if you cannot accept more queries, which means if the query count becomes more than, or your query size which you have, query size, query size. Now you might say, Aryan, why it is more than? Because if you see, my query count is 2, 3, and obviously my query count will actually be equal to 3 in the worst case, and that is the thing. I'm good. If it goes beyond, if my query count, which means k becomes 3, 4, sorry, then obviously I'm screwed up. So if the query count becomes more than equal to my query size, I'm screwed up. So I should simply return something. Now, obviously, what in worst case they were saying, do a -1. But now comes the fun part. Fun part says now you will accept that query which is at index qc -1. So if the query count is 2, his index is qc -1. So I will find the left, I will find the right, I'll find the value by querying queries of qc -1 and the corresponding 0 or maybe 1 or maybe 2, like to give respective values. Now comes the fun part. Fun part is how will you make sure that okay, you are at this specific query, right? You are at this index, right? So technically 0 to 2. So index 1 lies between 0 to 2, right? So will you write that if your I is more than equal to L, is more than less than equal to R, will you write this thing? If yes, then okay, you can write this, that's absolutely fine. But the question is that how will you update and what will you update? Like the question is, what will you update? Like, are you going to update your diff array at what index is the question? Because of obviously you will, as you actually, again, this is right now a hypothetical question, because right in the previous time, if you remember, we actually when we were at this index, my query already moved ahead. So it's kind of a hypothetical situation which is right now which we are considering. So the condition is that you are a specific query which is qc -1, index qc -1, and in the array nums of I, you are at this index. You realize that index 1 will obviously lie in this range, and if it lies in this range, I should incorporate it. But incorporate it, which means add a +1 and a -1 at what index? Obviously, -1 will be added at index 2 plus 1, which is 3. So I add that. But add +1 at index 0? No. Why no? Because I'm moving from left to right and 0 is already lost. Right now I'm at index 1. It is the reason I will say that okay, for diff array r plus 1 I will do a subtraction of value of I. Or I should say this v. But for L, ideally I should have done something of this sort, L. But again, L could be lost previously and I cannot go back. So I have to make sure that I will say that it should be maximum of my L, I comma L, and that is where I will add my value. And this is the entire catch, which is kind of, you have to make sure that how you are handling this case. Cool. And again, rest all is same, that when the while loop is completed, you will just simply add your sum. Where is this gone? Yeah, simply add your sum and say that add your diff array of I, and then ultimately return the corresponding query count, whichever you have got, this QC. Simply this QC is your answer. Return QC. This is your corresponding code. This is your code. Cool. Let's see the code exactly how it is. So exactly same. I have made a diff array, and then this is the sum, which is the prefix sum, and this is the query count. I'll simply go on to all the elements. For each element, check if right now it can. Okay, obviously sum, which is the prefix sum, plus my diff. If it is less than my nums of I, obviously I want more, because if it is more, only then my this I can become negative or 0. So if not, which means while this condition is satisfied, I'll increase my query count. And again, this is kind of a case that if the query count becomes more, I'm screwed up. Simply return -1. If not, then find your left, find your right, and find your value. As we said, that query count minus one is the index for the query. And obviously, if my right, if it is more than equal to my I, which means I can easily consider the current index inside my range. And then I simply consider it inside my range, and at r+1 I will subtract value at max of left, or I will add the current value. and ultimately making sure that when this while loop is done, you are doing something of this sort, right? This sort should be configured and said that, okay, for the next step, I am considering my diff of array of I, because now that diff of array of I is now properly done. That is the reason I am doing it post my while loop being done. So this is my corresponding while loop being done. Post it, I'm doing it because, again, why? Because it can change in this step, because you are adding things currently inside the while loop. So if you add in your sum here, it will duplicate or it will add more things. So it's the reason you have to add it outside and ultimately returning your query count. With that code, you see that you are going on to O of n, and for each, as we're using two pointers, technically it is O of q, but again it is O of n into q. No, it is not O of n into q. It is O of n plus q, because I am moving on to my n and parallelly I am moving on to my queries q. Thus, time is O of n into q. And obviously, you are using your diff array. That is the reason your space will be O of n. Cool. I hope you guys liked it. If you have any confusion in binary search or two pointers, make sure that binary search basis you watch this video. Two pointers, watch this video. And yeah, all set. Bye bye. Cool. Take care. And again, notes and stuff would be available here for LLD and stuff. And again, soon for these DSA videos as well. Bye bye. Take care.